repetitions. So this lesson is on box plots and mean deviation. So first we're going to talk about box plots. A box plot is a way to show data concisely. So it's kind of like a seven leaf plot where we're taking data and we're putting it into a representation that people can see and understand. Now, a box and whisker plot, okay, is also called a 5-point summary of the data because it's defined with 5 points, as you'll see in the example. Um, the 5 points that it shows are first, the lowest value, which is also called the lower extreme. So that's like when you're finding the range, you take the lowest number. Um, the second point is the lower quartile, or Q1, and that's from the lesson for the first part of the unit. The third one is the median, that's Q2. And the fourth is the upper quartile, which is Q3. And then the fifth and final one is called the largest value, which is also called the upper extreme. And then here we have an example of a box plot. So when you make one, you're going to start by making a number line. So just what I did here, and I'm just going to highlight that. Okay, the number line. And that just shows kind of the range of your data. That's how you know what numbers to put in there. And then what you're going to do is you're going to list out those 5 points of data that you have, because each of those 5 points means something and they go in a specific spot. So you take your lowest number, and let's say my lowest number is 7, then I would put that number here. Okay, I put a dot on 7 on the number line. It's kind of like when you put a dot on when you're graphing a inequality. So you can start by putting that dot there, and then your largest number is going to go here. That's called the upper extreme. The next thing you would do is find your quartiles. That's when you arrange your data and you find the median of the bottom half and the upper half, and then the median in the whole set of data. And what you do is you plot those as a line kind of on your own number line. And let me show that in red. So that would go here, Q1. Q3 is kind of the end of the plot. So that would go here. And then Q2, that's your median, and that goes here. And we're going to learn about what this box means. For example, why isn't it symmetrical? Okay. But one important thing to note is that inside of here, okay, inside of these highlight marks that I've done in blue, that's the interquartile range. That means 50% of the data is within this box. Okay. Now, if the median is here for the whole thing, that means that a lot of the data is higher, right, than the average, or than the median, okay, which is the middle part. So that's why sometimes, and a lot of times, it's not going to be symmetrical. So that's the usefulness of the box and whisker plot, because you can see things like, where's that, 50% range? Is that close to being symmetric? And we'll talk about kind of what symmetric means later on. And now we're going to get into some example problems. So for the first example, we're going to read this box plot here. It says, from the box plot, state the lower quartile, the median, the upper quartile, the range, and the interquartile range. So these are all things that we've gone over before. And so what we're going to do is we're just going to list these off. So it starts with the lower quartile, which is Q1. Remember, that's this spot here. And then it wants the median, which is Q2, which is that spot there. And it wants the upper quartile, which is Q3. And that's that kind of end of our box. And after that, it wants the range. Okay, so we need the upper and the lower extreme to find the range, and then the interquartile range. And for the interquartile range, we'll need these two spots here. So what's the range? And then the IQR, interquartile range. And so let's go ahead and find those. Those are just going to be plots that are kind of listed for us. Q1 is this line here, which means it's 4.5. Q2, which is the median, is this line here, which means it's 5.5. Q3 is going to be this line, and that's right on 7. The range is when we take the upper extreme and we subtract it by the lower extreme. So that's 9 minus 3.5, and that's going to give us 5.5. And the interquartile range, that's when you take Q3, which is 7, and you subtract Q1, which is 4.5. So you have 7 minus 4.5, which is then 2.5. And those are the 5 numbers that they're asking for. So that's it for that example. So we're going to scroll down now, and we're actually going to construct a box plot. So for this one, we have to find quartiles, right, in order to do a box plot. So we're going to have to list this data from least to greatest again. And you can pause the video and do that yourself. I'm going to stop recording and write that down now so you don't have to watch me write a bunch of numbers at once. And now that we have those numbers listed out, let's read the problem. It says 16 students took a quiz and their scores were, and then it lists out those numbers for us, and 4. Don't forget to put that. Draw a box plot for the data and label it with the 5-point summary. Okay, so we're actually going to do this backwards. It's easier to do the 5-point summary first and then draw the box plot. So let's find the quartiles. So we know that there are 16 students. That means it's an even number. So if I take 16 and I split that into 2 groups, it means I'm looking at the 8th number and the 9th number. So 1, 2, 3, 4, 5, 6, 7, 8th, and 9th. Right, so that's how I'm splitting them up. And what is the actual number? Well, remember I have to do 8 plus 8 divided by 2. Really, right, they're both 8. So no matter what, this is just going to be 8. You don't really have to do that if they're the exact same number. So my Q2 is 8. That's my median. And I did some shifting around so I can put the numbers here. So now I'm doing quartile 1, and that's going to be the median between these numbers here. So there should be 8 of them. So I have 1, 2, 3, 4, 5, 6, 7, 8. That means when I split them in 2, 1, 2, 3, 4, it's between 5 and 7. The average between 5 and 7. Well, when I add those together, I get 12 divided by 2 becomes 6. So my first quartile is going to be 6. My upper quartile, same thing, but the higher numbers here. I have 8 numbers, so I'm looking for the 4th one. 1, 2, 3, 4. So now it's going to be between 11 and 11. They're both 11, so I don't have to do any averages. It's just 11. The other 2 pieces of information I need for that for the box plot is the lower extreme. That's the lowest number, and that's going to be 3. and then the upper extreme. That's the highest number, which is going to be 15. And so I have my 5 points of data. Now I'm actually going to start drawing the box plot. So there are a couple different ways that box plots can look. It kind of depends on what number line you choose. So I'm going to do a number line that starts with 1. So we have 1, 2, 3, 4, and the more like spaced out these are evenly, then the better your data is going to look. But if you do 1, 2, 3, 4, 5, 6, 7, 8, it's not going to look good. So we want to make sure that everything is nice and even. The numbers are nice and evenly parted. So I'm going to pause the recording and make those numbers. Okay, now that we have the numbers, let's talk about actually making the box plot. So I need to put a dot, remember, on my lower number, which was 3. So here's my dot, and my higher number, which was 15. Okay, and I'm not going to worry about the line going through them. If you like to do that, you can. If you like to kind of draw a line through that, you can. Now I want to make my box. So I kind of have my whiskers. Now I want to make my box. And the boxes come with the quartiles. So my first quartile is at 6. That's the beginning of my box. And then my box ends at 11, which is Q3. And then that's the box right there. And usually the line, right, does not go through the box. So what we can do is we can just erase that line that's in the box. So if you like to make that line, you just erase it afterwards. Okay, and then you want to put the median in, which is the second quartile, which is at 8. And there you have it. So it's asking us to label it. So we'll just do that real quickly. So this one here is the lower. Then we have Q1, Q2, Q3, the upper. And I don't believe it's asking about an interquartile range or anything, so that should be the end of this example. So that was it for box and whiskers. It's pretty straightforward. It's just taking those numbers we did from the lesson on quartiles and putting them into a box and whisker plot. Now, what we're going to talk about here, okay, is called the mean average or mean absolute deviation. So I cut out from the book this kind of definition instead of writing one because I thought it was really good. This one says that it's another measure of variation, which is called the mean absolute deviation. So the mean absolute deviation of a set of data is the average distance of the data values from the mean of the data. So that's kind of wordy. Really what it's saying is that you're going to find the average, okay? So say you have like test scores, right? You find all the average of the test scores. You say that the average test score is a 92, okay? The mean absolute deviation says if the average is a 92, how many tests are farther away from 92? Are there a lot that are farther away? Are they all close together? Right? So how much do the numbers deviate from the average? Because if they deviate a lot, that means that that average doesn't really tell us much. Okay? Say you got like 4 100s and then two zeros, right? That's not going to be 92. But see how those aren't all around 92? So that's going to be a high deviation because they're not close to 92. Now, say you gave 26 tests, right? And everybody scored a 92. So the average was 92. The deviation would be 0 because it never changes, right? They're all 92. So it's really saying how far away are these points of data on average from being in the middle. And how you find it is this example right here. Okay, so suppose you have the data is at 1, 3, 7, and 9, and then the mean of the data is 5. Okay, so on a number line, you can see the distance of each data value from the mean. Okay, so what you're doing is you're taking each of these numbers here and you're saying, well, 1, how far is that away from 5? That's 4. 3, that's 2 away from 5. 7, that's also 2 away from 5. 9, that's 4 away from 5. Okay, so we're kind of changing our numbers from not what they were, but how far away they are from the mean. And we're taking these numbers, as you can see right here, and we're finding the average again. So you add them up. 4 plus 2 is 6. 2 plus 4 is 6. 12 divided by 4 is 3. So the mean absolute deviation is 3. What that data is telling us is that on average, the data is about 3 points away from being average. Now, here is a couple inferences that you can make with mean absolute deviation, which is also represented by MAD. All of the data is close to the average. So if you have a low mean absolute deviation, all of the data is going to be close to the average. So there's not much variation or deviation from the center. If you have a high mean absolute deviation, then the data varies a lot. There may be some numbers close to the average, but many are far away. So an example of something that's high would say like you have the numbers 100, 100, 0, and 0. So the average between those is going to be, if I add them up, I get 200 divided by 4, I get 50. So the average is 50. But look how far away all of these numbers are away from 50. Okay, so you could say, hey, you know, these test scores, on average, everybody got a 50. But not really, right? Because 2 people did really well and 2 people did really bad. So that's why we don't want to have a very high mean absolute deviation, because it shows that our data set is not close to each other. And we just have one more example, and that's about finding the mean absolute deviation from this set of numbers. So first we have to find the mean, which is just taking the average. Now in this case, because we're not doing any quartiles or anything, we don't have to order them, right? We're just taking the mean. And you do that by adding all of those numbers up and dividing by the amount of numbers you have. Okay, so let's start with part A. I'm going to add 54 plus 40 plus 69 plus 49 plus 73. Again, if you want, you can circle the ones that you've done. Plus 42 plus 35 plus 60 plus 51 plus 57. So the table shows the scores of 10 people in a dartboard game. And so let's make sure we have 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's make sure we wrote down 10 numbers. And we can actually do this as we write a fraction bar. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And make sure that that says 57. So we do 10 numbers, we're dividing by 10. When I add all of these numbers up, I get 530 divided by 10, and that gives me 53. Okay, so the average number is 53. So on average, people scored a 53. Now let's see how much that varies from person to person. In order to find that, okay, we're not done with part A, right? Because we have to take this average and see, well, how far away is that from all of these numbers, right? The easiest way to do that is with a table, right? We're going to see how far away all of those numbers are from 53. So let's set up a table. We've got our data. We've got the average, which I just found to be 53. And then last, we're going to find the difference. Or it's probably more appropriate to say distance. And we're going to do that for every number. So to show that, we need to write down all of these numbers into our data table. So our first number was 54, and then 40, 69, and I'm just getting all these numbers from the list of numbers that they gave us: 49, 73, 42, 35, 60, 51, and 57. Excuse me, 51 and 57. Make sure that that looks like a 51. Okay. The average doesn't change, so it's kind of 53 for every row. And while this can feel repetitive, if you have to do statistics and you don't have any technology, then you're going to have to get used to making tables, because that's a lot of what we do. Sorry, it's hard to draw fives with the Apple Pencil and my bad handwriting. All right, so the distance, that's when we do subtraction. We say, how far away is it? The easiest way to find the distance between them is just take the higher number and subtract the lower number. So in this first one, 54 minus 53, that's going to be 1. This one, 53 minus 40, which then equals 13. Okay, so I'm just taking the distance, or I'm subtracting the larger number from, or taking the smaller number from the larger number. So 69 minus 53, that's 16. You can go ahead and fill out this table if you want to pause, or you can watch me fill it out. Okay, but remember, all I did was I just found the difference between them. Now I'm still not done. I found the distances, I found the average. What I have to do to find the mean average deviation, though, mean average deviation, okay, is to find the average of these numbers. So take the average of the distance column, which are all these numbers here. So that means I'm going to be doing, it's going to make some space here. I'm going to be doing 1 plus 13 plus 16 plus 4 plus 20 plus 11 plus 18 plus 7 plus 2 plus 4. Divided by 10 because I have 10 numbers. And then you add those numbers up, you get 96 divided by 10, which is 9.6. So for part A, that means that the mean average deviation is 9.6. And what does that represent? Well, that says that on average, all of these dart scores, or scores from the dart game, are about 9 points away from the average. So that is a relatively low deviation. So that means that most people scored close to the average. Some outliers, right? Probably this one here. This player is really good, right? He was 20 points above average. This player too is really good. Okay, another player, this one here on the reverse side, not so great. Right, 18 points lower. If I take all those out, I'm getting closer and closer to what the average is. So that kind of tells you what outliers do. So when part B asks us to state what does the mean absolute deviation tell you about the data, it's just kind of a quick answer, almost like filling in the blank. You're just going to say on average, the data values are okay, and then that's kind of your fill in the blank. In this case, on average, the data values are 9.6 units away from the mean. Okay, so did a lot of work with data. Again, this one's about taking the average of the distance from an average. So you're taking the average twice. Can be kind of confusing. As you get closer and closer to statistics, mean average deviation is kind of a stepping stone to standard deviation, which is a more accurate representation of how close things are. But you're just kind of starting your journey into statistics, so you're starting to get used to kind of finding the difference between numbers and having to do that multiple times. Finally, I want you to do these 3 problems on your own and have your teacher check them. You're going to be, for the first one, just stating what the 5 points are in the box plot, along with the interquartile range. Number 2, you're going to be constructing the box plot, just like we did in example 2. And then the third one is finding that mean absolute deviation for the scores on this math quiz. And once you finish these problems, have your teacher check them, and you can move on to the practice.